So, welcome Barmias. Today I will talk a bit more about I will talk about Redstone artists, and I will go through the more known designs with the earliest in the more the earliest design that works just with torches and dust up to the current designs that are theoretics. So we'll that's a tutorial for Java and Bedrock. They work also in Bedrock, but Bedrock, instead of having glass, we should pull it using some glowstone or with upside down slabs. Good. So there we go. So that's probably the most known design because it was just the earliest one. At least that's what people came up with when they were building ads at first when Redstone was introduced in the game. So this one is probably the most known, and it works completely fine. I think maybe not in the first one or two versions in beta, but basically as soon as touches were not as buggy, it became the most popular design. And so this right there, I built a half adder. That's an XOR gate, that's an AND gate. When I turn one, this one turns on. When I turn the other, this one turns on, and this is always up. But when I turn both, this one turns off, and this one turns on. So that's a half adder. Now I will build the other. I will build the other XOR gate from the half adder to transform it into a full adder. So this right there is the carry in. We'll take this carry in and after a carry out. So there we go. That's the second. Oops. No. That's the second half adder. Good. And with that, what's good with that is that we can just stack it as much as we want. It will always work no matter the bits are. So good. Go out, and slash stack 7. Good. So now we have a 8-bit adder, and that's the carrying. So the output will be when this is off, the output will be A plus B, and when this is on, the output will be A plus B plus 1. Of course, you need the carry out because 2 8-bit number added to a 9-bit number can add it to a 9-bit adder. So that's the carry out, and that's everything we need. It's the really basic one is done. If you need something that is not synchronized, because this is a real carry adder, that means the carry gets calculated one after the other, and it takes quite some time. So that's why people no longer use this when they do some really complex things, because it becomes extremely slow. The addition is probably the most basic operation you could do in a computer, and this one does it in something like 2 seconds or so. So it's clearly not fast enough. To give a reference point, this adder, the first bit of this adder takes 6 ticks, so 0.6 seconds to calculate it, to be calculated, and the current designs only take 0.3 seconds for the entire 8 bits. 8 bits. That will be the last I will show you. Okay. So yeah, that's good, but it's not fast enough. Now I will build another one that was quite popular for a while because it's really easy to build, and it's not too complicated. The theory behind it is well known, and that is this object I do. So what is the change under this thing that was an XOR gate. So we did so that's the current XOR gate everybody uses, and that's the no gate for the propagation. So how this carry system works differently. How does it work is that when you input 1 and 1, it starts a propagation. When you put 0 and 0, 0, 0 in this bit, it stops any previous propagation to so basically it generates carry upwards, and it cancels carry upwards. That's why we call it a carry cancel adder, or CCA for short. And this way there, it's the final XOR gate, because when you have all these these carry calculated in parallel, you need to put them through a XOR gate to find the addition. So that's the final XOR gate. Good. Yeah. This one. Good. Now you need to put it through an XOR gate with the XOR of this bit. So yeah, that's what we do. Also, this is everything. It's everything parallel. So the output does not read like that, because this can and will break some circuits when you try to optimize. So it's not great for that, but if it works, it works. So this, I'm just putting the input there. So good. Good. And slash stack 7 up. Great. Everything seems to be working. So I shall now break something. So good. Oh. Good. And this is a working order. that's carried out, and then we can build the carry in. So that's the carry in. And that's where it goes. Good, it goes in this block and there. Good. Now I will just slash t freeze, turn on this and unfreeze the game to so that you see how does it work. Yeah, and so slash d and freeze. Good. See, extremely fast. Yeah, really good. Now it's not where we end because this one there is 5 ticks. That means everything gets calculated in half a second. And it's all synchronous, so that means you can chain additions. You can chain 3.33, so it's 3, 12, 33 hertz. So that means you can chain additions every 3 ticks. Which this one you can't because it's all the progression thing. And now this one is I don't know if you remember the first bit of this one takes 6 ticks, and the one I'm building now will take 3 ticks for the entire 8-bit calculation or byte calculation, as you wish. So so this this is the carry in. You go there and you build it like that. Good, good. Nice. And it's more. Also, if when you build this, you have something that doesn't work, the first thing you should check out is which competitors you put, what competitors have you put in subtract mode. Subtract mode is this one, and that's comparator mode. So be sure to check that. and it should work fine. Oops. Good. And there. Good. Nice. And the flush stack. System. Nice. There. Basically, what happens there is that this compartment might now get an input because it's too far away, so you have to put a barrel with one single strength, so barrel with anything inside really can be a block of dirt or something like that, and it will work. So yeah, no more fetish around that. So good. And this one, subtract mode. So basically, this one is the carry out. All these are the outputs, so the input output, and whoops. Good. And then it's carrying, so everything is nice. As you see, the thermal strength is stronger downwards, and it goes decreases when we go up. So that's just like how it is, because last I was a thermal strength that decreases with the distance, so we can't really do something about that. And yeah, it's quite good. And then I will just also flash tick. Breathe. Good. Oh yeah, no, it's this one. So that's the carry out, and that's the other bit. And slash tick. And breathe extremely fast. It's this one takes 0.3 seconds, and yeah, that's all I wanted to show. Have a good day, and yeah, bye.